Okay, those of you in second period know as we were going through this today, the district decided to restart my computer, and then the video did not save right and is corrupt, so I've got to repost that. So a lot of this is going to be written out. You're not going to see me writing it. It'll go a little bit quicker, but again, you should have this in your notes already. Remember factors, and we're talking about section 8.1, which is factors and greatest common factors. Two numbers that are multiplied together to get a product. A factor is two numbers, because you can only multiply two numbers at a time. It can be multiple numbers, but the numbers that are being multiplied are the factors. The product is the result of the multiplication that you just did. Factoring is the reverse of that, where you're trying to find the numbers or factors when you're given the product. Algebraic division is factoring, just like distributing is algebraic multiplication. We are involving letters and exponents, so therefore we have to call it a little bit something different. We've talked previously in here about how important 2, 3, and 5 are to us when it comes to reducing a fraction and breaking down a number. Any even number obviously is divisible by 2. Any number ending in 5 or 0 is going to be divisible by 5, and 3 is our next best option. When we showed this in class, we realized that the only numbers that were left were the prime numbers and 49. Well, 49 is 7 times 7. But my point being is it took care of breaking down all of those other numbers. A new skill we're going to learn today is called ladder division. That's L-A-D-D-E-R, division. We usually look at division with the divisor here and the number inside. We're going to flip that upside down. And our whole point is we're going to be trying to find the prime factorization of these things. And you're going to remember when you were in elementary school and you worked on finding the prime factorization of a number, where you did the factor tree and you multiplied 4 times the 5. And you realized the 5 was a prime number, so 4 was not, so you had to continue until you had all prime numbers on the bottom. And then when you got that, you wrote it all out as 2 times 2 times 5. We're going to be doing a lot of the same things, but we're going to do it a little bit differently. In that, if I took 20 and I put it underneath here, that's an even number, so I'm going to take 2 into 2, it goes 1 time, and 2 into 0 goes 0 times. 2 into 10 goes 5 times. I have the same factorization, but we're going to write it in exponent form. And there's a reason for that. We'll talk about it in a minute. 60. This is an important second step here. 2 into 6 goes 3 times. 2 into 0 goes 0 times. 2 into 3 goes 1 time. And there is 1 left over. That 1 left over and the 0 that's already there make a 10. So 2 into 10 goes 5 times. 5 into 15 goes 3 times. So I have 2 factors of 2, 1 factor of 3, and 1 factor of 5. Continuing here with a couple more examples. And again, over here, I chose to lead with a 2. When I had a 0 at the end. Here I'm going to choose to do the 5 with a 0 at the end. 5 into 40 goes 8 times. 2 into 8 goes 4 times. 2 into 4 goes 2 times. Make sure you always have a number down here at the bottom. 3 factors of 2 times 5. 2 into 52 is going to give us in another one of those borrowing situations, or carry situations, I should say. 2 into 5 goes 2 times, but 2 times 2 is 4. It's not 5, so there is 1 left over. And that 1 and the 2 that's there makes 12, so 2 into 12 makes 6. 2 into 2 goes 1 time. 2 into 6 is 3. Again, this is a prime number, so I know I'm done. 2 factors of 2 times 1 factor of 13. The next thing is we got to talk about common factors. And What does that mean? Well, factors we just talked about was the numbers that are being multiplied together to get a product. To be in common or to have in common means that we have something that we share or that's alike about us. Whether that be that we like soccer or a certain band or gaming or the color blue. Okay? Common means it is in both. Not everything about two people or two things is in common. There are some things that are not in common. But if I give you two factors of 18 and 25 and say what's the common factors, I'm asking you to find the factors and then determine which ones are alike. Well, as is with math, this would be a problem, that would be a problem. And now you got to do just as much work as you did up here for one problem. We just like to pile it on. So if I take 18 and I divide it by 2, I get 9. 3 into 9 gives me 3. 2 times 3 squared is the factorization. 5, because 75 ends in 5. 5 into 7 goes one time. And there are 2 left over, because 1 times 5 is 5. 7 minus 5, there's 2 left over. And that 2 goes with the 5 to make 25. 5 into 25 makes 5. Still ending in 5, so I'm going to stay with a factor of 5. 5 into 15 goes 3 times. So I have one factor of 3 and 2 factors of 5. These are the factorizations. The common factors would be those factors that are in both. 2 is not over here, and 5 is not over here. The only factors that are in both are the 3's. This is a factor 1 time, and this is a factor 2 times. They don't both have 2 factors of 3. They both have 1 factor of 3. So that 3 to the first is the greatest common factor. Similarly, if I'm asked to find the common factor of 20 and 36, it's the same kind of deal. I'm going to take 5 into 20. Notice on the first page I took 2 into 20. 5 into 20 gives me a 4. 2 into 4 gives me 2. 2 squared times 5 to the first. 36 is an even number. 2 into 3 goes one time with 1 left over. 2 into 16 is an 8. It's still even, so 2 into 18 gives me 9. 3 into 9 gives me 3. So the prime factorization is 2 squared times 3 cubed. To find the greatest common factor, I have to have those factors that are in both sets. 3 is not a factor over here, and 5 is not a factor over here. They both have 2 2's. They both have 2 2's. 2 squared is 4, so the greatest common factor here is 4. Now, as we progress through this, we now get involved in a little bit of algebra. Well, we're not going to make the algebra hard because we've done some work with exponents already. But now we are going to incorporate some variables in trying to find those greatest common factors. But not before it gets too far along. I'm still going to concern myself with the coefficient breaking down 12. 2 goes into 12 6 times. 2 goes into 6 3 times. So the factorization there is 2 squared times 3 to the first. And now I'm going to bring this x squared back down here. 2 into 28, because this is even. 2 into 2 goes 1 time. 2 into 8 goes 4 times. 2 into 14 goes 7 times. So the factorization is 2 squared times 7 to the first, and bringing in the x cubed. If it's the greatest common factor, it's going to be factors that are in both listings. This 3 is not over here, and this 7 is not over here. Factors of 2 squared are in both places, and then I have to evaluate x squared and x cubed. having 3 x's here and 2 x's here. They both have at least 2 x's. So 4x squared is the greatest common factor. And again, we just pile on with more stuff. More variables here. Same process. 27x cubed. Now 27, many of you got used to understanding and remembering that 3 cubed was 27. So if you see a number like that, 64, 125, 8, and you know it's a cube of some number, you don't have to go through this process. But if you are unsure, you can always check yourself right here. Again, once I've got the factorization done of the coefficient, I bring the exponents back in. 45 ends in 5. 5 goes into 45 9 times. 3 goes into 9 3 times. So I have 3 squared times 5, and I bring in the x cubed and the y squared. Now what has to be there? Has to be in the same thing. 3's are in both places. 5 is not. X's are in both places. Y's are not. So there are 3 3's here, 2 3's here. So we'll go with 3 squared, which is 9. And x squared versus x cubed, they each have at least 2 x's. So we will go with 9x squared as the common factor. Here's a little example to help you, a little trick of the trade, if you will. Six and 12. If you think there's a correlation for these, try to take the smaller number into the other coefficient. And if it goes, then you know this is the greatest common factor of the coefficients. 6 is 6 times 1, 12 is 6 times 2. Yes, there is a 6 in each of them. And we're going to see some more examples of this, but again, we didn't have it up here in the other examples. This is just a new type of problem showing you, hey, if these look like they can go into each other, let's see if they do. So you're going to bring down the 6 as the answer, and you can then just eyeball and say, all right, there are 2 x's in common. There are 3 y's in common, and there are 4 z's in common. And you're done. You don't have to go through all this mumbo jumbo up here at the top of the page. All right, and as is the case with math, we just keep piling it on. And now instead of having 2 numbers, we got 3 numbers. We want you to find the greatest common factor. And I notice a pattern of 4, 16, and 8. 4 is the smallest one. Does it go into 8? Yes. Does it go into 16? Yes. So 4 is going to be the coefficient. And again, ladies and gentlemen, I'm not going to lie, we're doing a lot of prep work here, helping you run through your multiplication tables. If you don't know your multiplication tables, you're going to have a hard time factoring. And it won't get easier for you until you know them. And you won't be able to use a calculator every time you turn around. You won't have time to complete the quizzes and tests. So you got to get working on those. If you need help with that, I've got some things I can give you that you can work on at home. I've got the 4, and I'm going to look at the exponents on the ends. I have 1, 3, and 2. They all have at least 1. So the common factor there is 4n to the first. A little bit more dangerous here. Bigger numbers, more variables, higher exponents. 27, 18, and 81. 27, 18, and 21. What number goes into all of those? Well, I'm not sure if you know, but multiplication facts of 9, these 2 numbers always add up to 9. And that's 9, and that's 9, and that's 9. So 9 goes into each of those. Does 18 go into all of them? That's really the smallest number here. Does 18 go into 27? No, it doesn't. No, it doesn't. So 9 is going to be the common factor. I have y cubed, y to the 5th, and y to the 7th. Each of these has at least 3 y's in it. You can check yourself. 9 times 3, 9 times 2, and 9 times 9. If I take out the 9, then what's left is 3 and 2, and those are not in common. If they had a number here that was in common, I'd say, all right, well, maybe there is a bigger number, but these numbers are not. So 3 and 9, they have an additional factor of 3, but the 18 has an additional factor of 2. So it doesn't have a larger coefficient for us to take out. All right, so where do we go from here? Now we start looking at algebra. And now we start looking at polynomials. We know that this is a binomial, 2 terms separated by the addition sign. The orange is a sign and the pink is a sign. And if I'm going to break down 21 and 9, I am going to take 3 into 21 and get 7, 3 into 9 and get 3. The only factor that is in common is 3. And each of them has 1x. So I'm making fractions out of this. Remember, factoring is algebraic division. Fractions are division problems. We did this in last chapter when you just had one term. And you divided the top by the bottom and subtracted the exponents. You're going to do the same thing, except now you're going to do it twice. All right, so 21 divided by 3x. 3x has been determined to be the common factor. That is what I am dividing out. When I divide 21 by 3, I get 7. When I take x squared divided by x to the first, I subtract the exponents. 9 divided by 3 is 3, and x to the first over x to the first is itself. So this is the number that, or factor that they have in common, and these are the other factors, or the ones that they don't have in common. Similarly here, 15x to the fourth y squared minus 10x cubed y cubed. This is pretty easy for me to figure out that 5 goes into both of those. 10 doesn't go into 15. 5 is going to be the biggest number. So if I can figure that out, and I'm really confident of it, without doing that ladder division, go for it. 5 is a common factor. Looking at x to the fourth and x cubed, the most number of x's in both of them is x cubed. Y squared and y cubed, the most number in both is 2. In both is a key there. So I'm going to divide by 5, x cubed, y squared on both of these. This is my common factor. 15 divided by 5 is 3. X to the fourth over x cubed is x to the first. And y squared cancels. Any number over itself is equal to 1. Minus, big key, 10 divided by 5 is 2. X cubed cancels out. Y cubed over y squared, subtract the exponents, and 2y to the first are the not in common part of the factorization. Okay? I had you try these. I'm going to write these down, but I'm going to pause the video so it's not sitting there, you looking at it and space running. Write these two down, pause the video, and then answer them. See if you got the same answer that I did. Okay, we're back. And we're going to look at this example here. Numerically, 8 goes into 16. That's the easiest and fastest way to find that numerical common factor, greatest common factor. If 8 goes in, or any number goes into the other one, then that is the common factor. So 8 goes into both of them. Looking at the variables, x cubed and x to the fifth, they each have x cubed in them. So 8x cubed is the common factor. I'm going to divide that out of each of them. 8's cancel, x cubes cancel, leaving me 1. 16 divided by 8 is 2. X to the fifth over x cubed is x squared. You got to have the largest common factor. In 2 classes, this caused problems today. Not a problem for us as we learned from it, but we had the same mistake because we thought we were going to take out just 4. 8 goes into both of them, so it's really the common factor there. Over here, looking at 5 and 9. Well, there's nothing common about that. 5 is 5 times 1. 9 is 3 times 3. They don't have any numbers in common. The only thing they have are these variables, x cubed. So x cubed goes in the denominator and up here, and when I cancel, the 5 is left, and x to the first in the denominator. Cancel here, and 9 is left in the denominator here, or the numerator here. This is my common and my uncommon parts. Okay, this is the last one on this side of the video. Again, I want you to do this by yourself. I'll give you a second to write those down, and I'll come back to it. Pause your video now. Okay, again, as in the problem before, we have the coefficients 5 and 10. 5 goes into 10, so 5 is the greatest common numerical factor. X to the fourth and x squared, there are 2 x's in each of these. There's a y over here, there's no y over here, so there's nothing in common there. So 5x squared is the common factor. You will write that down and then do your math division that we did last chapter. 10 divided by 5 is 2. X to the fourth over x squared, you're going to subtract and get 2. 5 divided by 5, don't forget that minus sign, is 1. X squared over x squared is 1, and y cubed is left there by itself. These are what's common factors. These are not in common. 9, 6, and 18. 9 goes into 18. 6 goes into 18. Does 6 go into 9? No. So we got to drop it down. The next number is 3. 3 goes into 9. 3 goes into 6. 3 goes into 18. The lowest power of x is x cubed. So all terms have at least x cubed in them. So 3x cubed is the common factor. And again, by writing this as a fraction, we use the skill from last semester about simplifying each of these monomials. 9 divided by 3 is 3. 5 minus 3 is 2. Negative 6 divided by 3 is negative 2. 4 minus 3 is 1. 18 divided by 3 is 6. And x cubed goes away. Okay? So, the rest of these are on the next video. I'm not going to be redundant and go through them. We'll stop now. When you get done with this, please pick up with the second video.